Hello guys and welcome to 64 Tech Bits. We are back with another video in Java series, and in this video we'll be looking into data types in Java. What are primitive data types? What are the different type of data types and their use cases? And why exactly do we need them in our Java programs? So let's get started. Here you can see there's a definition of primitive data types, which means that it specifies the type of variable and the kind of value it holds. Right? Now, what are variables in general? Right? Why do we need data types in the first place? So let me scroll down for a bit and assume we have, okay, let's say this is your memory of your device and we have to perform a basic arithmetic operation. You can directly say print 10 plus 20, right? You'll get the output as 30, which is fine. But let's say I want to store this value, each of these values in the memory, and I want to use them later, or I want to store the result and store them and use them later, right? When we want to store this value in our memory, we'll define a variable, let's say x. Now x equals 10, y equals 20, and let's say total is equal to x plus y. Here we have three variables, as you can see, x, y, and total, right? Now to store these values in our memory, we'll use data types. Now data types are a way to define what kind of value these variables would hold, right? So let's say here we have integers, so 10, 20, and hence we are adding integer plus integer, we'll get another integer. So this will be 30. Now, when we're trying to store these values in our memory, we'll specifically define what kind of value it stores and what size will it take. So here we have x, which will hold 10. Here we have y, which will hold 20. So, and here we have total 30. Now let's say if I modify the value of x from explicitly defining it as 30, right? Now this will become 30, but it won't affect the other values until we perform or run this command, right? So when we run total x plus y, so you can see 30 plus 20 equals 50. Now let's look into what kind of different primitive data types we have. Okay, so the first primitive data type is byte, which stores values within the range minus 128 to 127 and holds the storage of 1 byte. Short holds the value within the range minus 32,768 to 32,767 and it takes 2 bytes of memory. The next one is integer, which stores the value within the range minus 2 power 31 to 2 power 31 minus 1 and it holds the space of 4 bytes. It takes 4 bytes of memory. Now minus 2 power 31 can be approximately 2 billion. So if your value that you're storing is within 2 billion range, you can use int. If it's over that, you have to use long. It takes 8 bytes of memory. We have different primitive data types to store fractional numbers, that is float and double, where float stores 6 to 7 digits. Okay, let's skip this. Where float stores 6 to 7 digits of decimal digits and it takes 4 bytes of memory, whereas double stores 15 to 16 decimal digits and it takes 8 bytes of memory. We have different type of primitive data type to hold true or false values, which is Boolean, and it takes 1 byte of memory. And the last primitive data type we have is char, which holds a single character or a specific ASCII value, and it takes 2 bytes of memory. Now, what exactly are ASCII values? We'll get in the later part of the video. Now, one would ask, how does a program know which kind of variable I want to use or which data type do you want to specifically use? In this case, in a program, when you want to define a variable, you need to extensively define which data type has to be assigned to the variable. Now, let's say I want to use character data type, right, or char data type. I'll say char ch is equal to something. Now, ch is the name of the variable which holds something and is of type char. Okay, the integer data types like byte or short are not specifically made for arithmetic operations. So when you perform arithmetic operations such as addition, subtraction to either byte or short, the result has to be externally typecasted, right? You can externally typecast using brackets byte or brackets short. Now, what exactly is typecasting will be covered in next videos, but for now, keep this in mind. Let's understand each of these data types with a Java program example. We are using the same class as before, so let's remove this. So let's get started with the basic example that I said. Int x equals 10, int y equals 20, and int total equals x plus y. And we'll do system dot out dot println, and we'll say total, right? Okay, space plus total. Now here you can see total is a string and this total is an integer value. Now this type of operation is called concatenation, where a string value and an int value is concatenated in a print line or a print command. Let's run this program. Here you can see the total is 30. Now what happens when I update the value here? Now let's say x equals 50. Will the value of total change here? No. Let's run this to find out. And you can see the total is still 30. Why? Because when we are printing this, the value of x hasn't been updated yet. But what happens when we use it here? Right? So I'll say total plus total, right? And run this again. Here you can see total is 30. Total is again 30. Why? Because the total operation has been performed here, where the values of x and y were 20. So to update the value here, we need to use it again. What happens when we do this? Run the file. Now you can see the value of total has changed because we performed an arithmetic operation here. Okay, so this is an example of how we use int data type. Now let's use the basic data type, that is the byte. Now byte x equals 64, 65, and byte y equals 47, right? And let's say byte totals equals x plus y. Now here you can see we are getting a man. Okay, provided int this explicitly where we are mentioning the type of the value we desire is called external typecasting. More about typecasting will be discovered in later videos. But for now, if we are adding two values of byte and we want to add them, we'll have to externally typecast it before performing the operation. Let's print this thing. Total. So what do we expect? Click run. And here you can see the answer is 112. But if you remember correctly, the range of byte ranges within minus 127 to 128. But what happens if the value exceeds 128? Right? Now let's make this 76 and run this again. Yep, minus 115. Why? Because let's get to iPad and understand why it gets to 115. Here we have byte object 1, which is 65, and we have byte y is equal to 78, if I remember correctly, right? No, 76. So 76. If we technically add it, so 65, 76, which goes 1177, 141, right? Now, if we minus 127 from this, we'll get 14. And if we go in the number system, we can see the range of byte ranges from minus 128 to 127. So if your number exceeds from 127, it goes back to minus 128 range, and it's deducted from there, or it gets moved from there, right? So here we have minus 128, 27, 26, 25, 24, 23, 22, 21, 20, 19, 18, 17, 16, and 15. And if we count the numbers, we should get 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Hence, you get the answer as minus 115. Now let's get to different kind of data type. We have short. So let's just change all of this to short. And what happens when we remove the type casting? We'll get the error. So here we have to make it short. Short and short. And if you remember the range of short ranges from minus 32,767 to negative 32,768. So let's say if the value of x is 20,000 and the value of this is 15,000. And what is the expected answer? Minus 30,536. The same principle is applied here. When the range exceeds in either int, short, byte, it goes from the negative cycle, right? Let's say if we exceed the positive side of the values, it goes to the negative side of value. The excessive part goes to the negative side of value and we move forward. But if we are going in the reverse direction, let's say if this was minus 20,000 and minus 15,000, the answer should be 30,535. Oh yes, just the minus symbol goes away. Now this is a clear example where we understand if a range of numbers, it can be byte, short, or int. If a positive side of bound or the upper bound is passed, the excess is moved on the negative side and it gets added to it. If we surpass the negative bound of it, the excess is being subtracted from the positive range. You should always remember the range of numbers you are operating on and use the specific type of data type. So if you are working with numbers which will result in greater values than 65,000, 32,000 positive to 32,000 negative, you should use int instead of short. And if your integer value is exceeding 2 billion, negative or positive, you should use long. Okay. Now that we have covered byte, short, int, and long, we'll go with fractional numbers. There are two data types, as we discussed, float and double, which holds the fractional part of the data. Now let's say if this was, let's make it float first. Float is an error. We do not. This wouldn't cause an error. We don't need external typecasting while working with float data. Now let's say if this was 15,000 and this was a prime number, let's say 37. and I divide it x divided by y, what should be the total? Yep. So the answer is 405.4054, right? So the float is used to hold the numbers with decimal parts, and it can hold up to 6 or 7 digits. Let's use an example which we know, 22 by 7. Now what happens when we do 22 by 7? We see a non-recurring decimal, right? So let's run and see if that's the case. Yes. So here you can see it holds 1, 2, 3, 4, 5, 6. 6 digits of decimal. But what happens if I change the float to double? And let's run for the same example. Here you can see it goes a long range, right? Although we can see it's a repetitive part, here it goes repetitive, right? We can represent it using bar in mathematical terms, but in programming terms, it is what it is, right? And we covered float and double. The next two primitive data types have their specific use cases, which is Boolean and char. Now, Boolean check is either true or false. So, check. What if we print this? It's basic, true. If you make this false, it's false. Booleans are specifically used in conditional statements. We'll learn about conditional statements in the coming videos. But for now, remember why Booleans are used, okay? The next we have is char. Now, char, as it suggests, it holds a character value, right? Now, let's say a, right? And print this, you'll specifically get a. What happens when I cast this in int? When we do an external typecasting using int, we'll get the ASCII value of it, right? And to understand what ASCII values are, you can simply open a web browser and search for ASCII codes, and you can go to ASCII table. Here we have code for each of the characters used in English language or symbols in general. Yep, here you can see ASCII value 97 for lowercase a. If what happens when we do the reverse? We'll make this int and we'll do it 205, right? And instead of int, we'll do character typecasting and run check. We'll get equivalent ASCII character. Okay. So char values are used to specifically hold character values. Char data types is used to hold a single character of any characters within the ASCII table, and these have very specific use cases. We'll learn about these specific cases in the coming videos, but this was all about primitive data types. Let's learn about non-primitive data types. Although they are a bit complex and we won't be covering it in this video, but let us know what are the non-primitive data types in general. Here you can see the non-primitive data types. The non-primitive data types are mostly referred as instances or objects. And instead of storing the exact value that in the previous example, here you can see x equal to 10 and y is equal to y, they hold the memory address of x and y, right? And these are majority user defined. Now, and the different types of non-primitive data types include arrays, classes, string, interfaces, and enum. Now, each of this will be covered in a different video because each of them have many things to be explored, right? So that's all for today, and that's all for this video. We'll learn about each of the non-primitive data types in the coming video. So like and share the video, subscribe to the channel, and we'll meet in the next video. Bye bye, take care.